Hi everyone, in this video I'm going to work through an example in order to show you how to solve a constrained optimization problem using the Lagrangian method. Okay, so for our example, let's consider this simple model of a household who wants to maximize consumption across 2 periods and also to maximize savings. And as you can see, they have the following utility function, log C1 plus log C2, and they are also subject to a budget constraint in each period, as you can see here, where Y represents income, S is savings, and R is the interest rate. And now, let's say we have been asked to find the Bond-Euler equation for this model. So just to be clear, the Bond-Euler equation is an equation where the only variables are C1 and C2, so describing the intertemporal trade-off between consumption in period 1 and period 2. So to solve this model using the Lagrangian multiplier, the first thing I'm going to do is find the intertemporal budget constraint. So I'll begin doing this by rearranging both the period budget constraints in terms of S. So this is what that will look like. C1. So that's for the first period with S on one side of the equation. And then for the second period, we will have And now we can combine these two equations to eliminate S, which will give us our intertemporal budget constraint. So that will be and now we have our intertemporal budget constraint. And now the final step before we can form the Lagrangian multiplier is to set one side of this equation equal to 0. So we want to do this by subtracting the period 1 side of the equation from the period 2 side. So that will look like 0 is equal to, and then the same as what we had up here, and just minus the terms from period 1. Great. Okay, so now we're ready to write the Lagrangian multiplier equation. So this is how it will look. L is equal to, and then we just rewrite our utility function given in the model. So L is equal to log of C1 plus log of C2. And now we write lambda, plus lambda, simply multiplied by this equation that we found from the intertemporal budget constraint. One plus R minus C1 plus Y1. And so there we have it. That's the Lagrangian multiplier equation. Okay, so the next step in solving this model is to differentiate the Lagrangian equation with respect to C1 and C2 in order to get the first order conditions. So first I will differentiate with respect to C1, and that will look like this. 0 is equal to 1 on C1, just using our log differentiation laws. And then we will have minus lambda, because minus C1 multiplied by lambda, differentiate that with respect to C1 gives minus lambda. And we can rewrite this equation as lambda is equal to 1 over 1 on C1. Now, differentiating with respect to C2, we will get 0 equals to 1 on C2, again using our log laws, and then plus lambda, and then over 1 plus r, just differentiating this bit. Now this, if we rearrange this, it will give us minus 1 plus r over C2 equals to lambda. And now we can equate these equations to get our Bond-Euler equation, which will look like this. Just combining these two equations, and now this is the Bond-Euler equation we were looking for. So as you can see, it describes the intertemporal trade-off between consumptions in period 1 and period 2. Great, so now we've solved this model, you could also go ahead and solve for the optimal level of S, just using algebra from here. But that's it for the video, so I hope you felt you learnt a better understanding of using the Lagrangian multiplier for solving these kinds of constrained optimization problems, and I'll see you later.